Let's suppose that we want to weld these two bars together, one on top of the other. In which direction should we bring our hammer blows? If we hammer from the end of the bar, the two surfaces are going to slide past one another because they're in a shear plane, they're not in a welding plane. We need to hit 90 degrees to the two surfaces, so the two surfaces are put in a welding plane. The problem with that is the ends of the bar, unless we do some treatment to them, are still in a shear plane. If we continue to weld like this, what's going to happen is we're going to have cracks forming in our weld once we've finished. If we put a slight slope on the ends of our bar, then as we hit, everything is in a welding plane, nothing's in a shear plane. So now the two surfaces will go together, forming a diagonal weld. Another aspect in forming a scarf is the anvil effect of a bar. If I hang a bar from the ceiling, it's all hot, as hot as you like, I don't care, and I deliver a hammer blow from one end, that end will be deformed due to the inertia of the bar. The other end will not be deformed. A bar can act as its own anvil. I can bring that into my two welding surfaces because if I look at the bottom bar, it's going to act as an anvil. The top bar will spread, forming little wings at the toe of the scarf. I need to thin the toe of the scarf so it's narrower than the bar to which it will be welded. Let's add that all together now. We know we want the toe of the scarf to be narrower than the bar to which you intend to weld to counter the anvil effect. We know we want the bar to have a slope on the end, so everything's in a welding plane, not in a shear plane. If we put those two pieces together, we have a scarf. Let's see what that looks like in real life. So I'm going to hold my bar at about 20 degrees or so, and then double that angle with my hammer, so the bar bisects the angle between the anvil and the hammer. And now I'm going to work on both sides and create a short blunt taper. Maintaining the hammer angle, I'm going to turn this 90 degrees, drop it down so it's level with the anvil face, and draw the toe of the scarf. Dress the sides. And now I have a three-sided taper. So I'm happy with my weld there. Typically, when we join two bars together, we put a slight step in the scarf. This so we don't overlap too much or too little material. Don't make the step too deep because the step is in a shear plane, it's not in a welding plane. Now you'll notice that there's plenty of material in the main body of the weld. We're not wanting for material there. But either side of the weld, that's subject to a scaling heat and thinning blows. So we need to upset these areas prior to going to our welding. Typically, you can just upset the end and then draw down to make your scarf. But now you're drawing down larger material, and that could affect the length of your scarf. You could end up with a long toe, and a long scarf is not a stable scarf. We'd like a shorter scarf. So what we can do is shorten up the upset by upsetting either into the step or into a block. So now when we draw out the scarf, we don't have as much material to deal with, and we end up with a shorter toe to our scarf. Now when I flux a bar, what I like to do is bring it out at as high a welding heat as I can, or a higher heat as possible, and then I apply the flux. I believe there's a degradation of the flux in the forge environment. See how that looks wet and runny? Okay, that's what we need to keep going, so we're actually going to put that back in the fire, bring it up to a welding temperature, and then have a look at it. I've got a nice bright orange of the coals above and beside my piece, so when I bring this out now, you can see nice bright orange. The flux is still liquid, it's running around. As it cools or oxidizes, you can see those black spots coming from the bottom of the screen there, making the way to the top of the bar. At this stage you're fighting scale. Those are going to be included in your weld. And right now you're not going to weld. Look at the way those black spots are creeping up the bar, the way the air's reacting with the flux, forming scale. That scale is a barrier to your weld. So you cannot weld when it looks dry and crusty. It has to look wet. Let's turn it over. Here the flux is not degraded quite so much. There it goes. And now you've got scale forming.